Hello everyone, I'm Abhishek, and in this video I will talk about the second part of integration by substitution. So mainly in this video I will focus on solving different questions of different importance. Now I must say that you have to solve as much as possible this integration by substitution, then only you will develop a better idea of how to solve integration. Now in previous video we have learned that if integration of small fx with respect to the variable x be capital Fx plus c, then integration of f of gx into g dash x with respect to the variable x is capital F of gx plus c. So there we have to consider gx equals to t. I gave the proof in my previous video, you can go and check. So there we have to assume gx as t or any other variable z also. So this is called the proper substitution. Now if we consider that, then g dash x dx, this g dash x dx will become dt. So that means you have to differentiate gx. Now here I want to say that you should have a nice command on differentiation, because you have to check that which function I should take as t so that g dash x is present there. So I must suggest that if you can do differentiation in your mind, then it will be better. Now let us see some examples. So in this video I have solved around 20 questions. So let's see the first question. The first question is very easy. This is x cube into 1 plus x to the power 4 whole to the power 3 dx. Now we can see that x to the power 4, the differentiation of x to the power 4 is actually 4x cube. And in fact there is a constant term here. So if we take the whole thing as t, so therefore it will be 4x cube only. So 4x cube dx should be equals to dt. So before that I assumed this integration as I. So I can be written as 1 by 4 into 4x cube. See there is no 4. So we need to make there 4, because we need a 4 here, 4x cube dx. Then only we can write 4x cube dx as dt. So we need here a 4, so that there will be 4x cube dx. So that is why we need to multiply 4 and divide 4. Okay. So therefore it will be 4x cube dx will become dt, and this is 1 plus x to the power 4 is considered as t. So therefore 1 plus x to the power 4 will be t, then there is a whole cube, so t cube dt. Now a simple integration. The integration is t to the power 4 by 4. So it will be t to the power 4 by 16 plus c. Now at the end just replace t, that will be x plus 1 plus x to the power 4 whole to the power 4 by 16 plus c. This was the first example, which is very simple. Now let's see the second question. The second question is given that 4x plus 1 by root over of 2x square plus x minus 7. Now you should see that 2x square plus x minus 7, if you take this thing as a whole, so what is the differentiation of that? It will be 4x plus 1, and this one is 0. So 4x plus 1 is already there. So that means 2x square plus x minus 7 will be considered as, you can consider here z also, but since there is a square root, so that is why to avoid this I put z square. So that after putting z square here, it will be z. Nothing else. You can take here z also, no problem. So 2x square plus x minus 7 should be equals to z square. So now if we differentiate this, then it will become 4x plus 1 dx equals to, now the differentiation of z square is 2z dz. So therefore 4x plus 1 dx will be replaced by 2z dz, and this will be replaced by root over of z square, root over of z square. Now root over of z square means z, and this z cancel out. So it will be just integration of 2 dz, which is 2z plus c. Now we know that since z square is this, so z will be root over of 2x square plus x minus 7. So therefore 2 into root over of 2x square plus x minus 7 plus c. Now let's see the third question. Here the third question is root over of 3 plus log x by x dx. Okay, so we need to find out the integration. Now we know that log x differentiation is 1 by x. See there, x is there in the denominator, so 1 by x we can write 1 by x dx. So that means log x. Now with that log x there is 3. So now if we consider the whole thing 3 plus log x, then also we can do the same thing. So therefore 3 plus log x, again I am considering here z square because there is a square root. You can take z also. In my next after some questions I will solve some question where I have taken only z, so you can see there. So there is no problem. So 3 plus log x equals to z square. Now if I differentiate it, this will be 1 by x and this is 0. So 1 by x dx equals to 2z. Z square differentiation is 2z dz. So therefore 1 by x dx equals to 2z dz. Now again if I take this integration, so here we can see that 1 by x dx will become 2z dz. So it is replaced, and this is root over of z square. Now root over of z square is z, so this will become 2 into this 2 will go out from this integration, 2 into z square dz. Now which is 2 into z cube by 3 plus c. Now again I have to replace this value. Now value of z is root over of 3 plus log x. So it will be root over of 3 plus log x whole cube 2 by 3 plus c. So integration by substitution is nothing but you have to understand which function is the differentiation of what function. Now let us see the fourth question. Here it is a different kind of question. We can see that 3x plus 1 into x plus log x whole square by x dx. Now you have to see the function in such a way, this integral in such a way that how we can take a function so that the other thing will be the differentiation of that function. Now if we see that x plus log x, if I take x plus log x as t, then what is the differentiation? This will be 1 plus 1 by x. Now here also x plus 1 by x. Now if we give this x to this factor and if we distribute this x, then it will be 1 plus 1 by x. See, 1 plus 1 by x is there. So you have to see, you have to see the function and you have to judge what should be the proper substitution. So that is why you have to practice more. Now x plus log x equals to t, if I take, then 1 plus 1 by x dx will be dt. Now this 1 plus, this is 1 plus 1 by x, so I have written that I in this way. This 3 will come outside. Integration of 1 plus 1 by x, I have given that x as I told. So into x plus log x whole square dx. Now this into dx will become dt. So there is a dt. Now this is t, the whole thing is considered as t, so t square. So therefore it will be 3 into 3 is outside, so that is why 3 into t cube by 3. Now this will be t cube plus c. Obviously it will be x plus log x whole to the power 3 plus c. So in integration you can see that whatever you are substituting, you have to differentiate that one. Now let us see the fifth example. So it is given that sine inverse 2x whole cube by root over of 1 minus 4x square. Definitely if we differentiate sine inverse 2x, I will get this expression in the denominator. So let us take sine inverse 2x as y. So it will be, now if I differentiate, it will be 1 by root over of 1 minus 2x whole square into a differentiation of 2x. Now differentiation of 2x is chain rule. So 2 into dx. So that will be equals to dy. So that means we can write 2 dx by root over of 1 minus 4x square equals to dy. Now here we need a 2. So that 2 is not there. So that is why I have to multiply and divide 2. So divided 2 and here I multiplied 2. So this thing will become dy So dy, and this thing will be y, so y cube. So therefore 1 by 2 y cube's integration is y to the power 4 by 4, so it will be 1 by 8 y to the power 4 plus c, and at the end y will be replaced by sine inverse 2x whole to the power 4 plus c. Now I want to say one thing, that don't write this as sine to the power minus 4 2x, because it is inverse function. There is a functional inverse. Okay, sine inverse is not 1 by sine 2x. So don't do this thing. So it will be 1 by 8 sine inverse 2x whole to the power 4 plus c. This inverse is the functional inverse. Now let us see the sixth question. So this is cos cube ax plus b into sine ax plus b dx. Definitely if you take cos, then the differentiation will be sine. So therefore I have to take this cos ax plus b z. Then it will be minus a sine ax plus b dx will be equals to dz. Now minus a is not there, so I need to bring that minus a, so I need to divide minus a. Done. So therefore this will become dz. So this is dz, and this will become z cube, since cos ax plus b is z, so cos q will be z cube. So this will be 1 by a is already there. Now z cube's integration is z to the power 4 by 4, so 1 by minus 1 by 4 is z to the power 4, and now replace the value of z here. Now the value of z is cos of ax plus b, so cos of ax plus b whole to the power 4 will be equals to cos to the power 4 ax plus b plus c. Now let us see the seventh question, and it is given that tan x by root cos x dx. What will be the integration of that? Now tan x by root cos x. Now tan x can be written as sin x by cos x. So once I wrote in this form, now again we can consider cos x as z, since we know that cos x differentiation is minus sin x. So important is which function is coming. Okay, minus is not important. The constant part, the multiplied constant part is not important. So cos x integration is minus sin x. So therefore we can consider cos x as z square. Why z square? Because there is a root cos x, so that is why z square. So cos x will become if we differentiate both the side, it will become minus sin x dx equals to 2z dz. Now we can adjust this minus sign. So to adjust that, we need to multiply minus 2 times. So therefore minus of minus sin x dx by this. Now minus sin x dx will become 2z dz, and this will become cos x is z square, so this is z square, and this will be z. Now these two z cancel out, so it will be 2 by z square dz. Now we can integrate 2 by z square by taking by considering the z square as z to the power minus 2 because it is in the denominator. So minus 2 into integration of z to the power minus 2 dz will become this, z to the power minus 2 plus 1 by minus 2 plus 1. Now z to the power minus 2 plus 1 will become minus 1, so it is z to the power minus 1, and there also minus 1, so this minus and that minus will become positive, so it will be 2z inverse plus c. Now 2z inverse means 2 by root over of cos x, z inverse means 1 by z, so therefore 1 by z means 1 by root cos x, so 2 by root cos x plus c. Now let us see the 8th question. So it is given that 2 tan square x plus 2 into secant square x by tan cube x plus 2 tan x plus 5 dx. So we need to integrate that thing. Simple. Tan x, we know the differentiation of tan x is secant square x. So that means tan x we need to take as a substitution. So tan x equals to z, secant square x dx will be dz. So here important thing is which function you are taking as a substitution. So if you can find out the proper substitution, then the answer question will be very easy. So this will be dz, so this is dz now. Now this will become 3z square plus 2 by z cube plus 2z plus 5. Now here again we can see that we have to do the substitution. Why? Because z cube's differentiation is 3z square, 2z's differentiation is 2, and 5's differentiation is 0. So therefore again you take this one as another variable y. So it will be 3z square plus 2 dz will be equals to dy. So we can write the integration as 1 by y. Ultimately this thing will be dy. 3z square plus 2 dz is equals to dy, and this will be y. So it will be 1 by y dy. Now integration of 1 by y dy will be log of mod y plus c. So it will be log of mod. Now y, we have to convert y to z first. So it will be z cube plus 2z plus 5 plus c. Now z will be converted to tan. So since z is tan x, so therefore log of mod tan cube x plus 2 tan x plus 5 plus c. Now let us solve question number 9. So question number 9 is to integrate cot to the power 4x dx. Now here we need to adjust this integral first, because we know if we differentiate cot x, it will come cosecant square x. Okay, so we need to but there is no cosecant square x, so directly it will not come. So first we need to adjust. So what we have done, so integration of cot square x into cot square x. Now this cot square x is written as cosecant square x minus 1. We know this from class 10. So therefore now we can distribute this. So it will be cot square x into cosecant square x minus again cot square x dx. Now we can distribute the integrals also, integration also. So therefore integration of cot square x cosecant square x dx minus cot square x dx. Now this one is a simple integration, okay, because if you make it cosecant square x minus 1, it will be simply done. But this one we need substitution. So for that I have considered this one as one integration I1 and this one as I2. So I will integrate both separately. So let us take the first integration I1. I1 is cot square x into cosecant square x dx. So here simply you can take cot x as z. So it will become minus cosecant square x dx equals to dz. So we can write minus cosecant square x dx. So we need a minus, so we need to multiply minus 2 times. So minus cosecant square x dx. Now minus cosecant square x dx will be dz, and cot x is z, so cot square x will be z square. So minus integration of z square dz, which is z cube by 3. So minus 1 by 3 cot cube x. Why cot cube x? Because z is cot x plus c1, another constant c1, integrating constant. Now next one is I2. I2 is simple, as I told, that you need to make it cosecant square x minus 1 dx. So it will be integration of cosecant square x minus dx. It will be minus cot x minus x plus c2. So I2, we got I2. Now what we have to do, I was I1 minus I2. So therefore I is equals to I1 minus I2. Just you have to put the values here, simplify this, and at the end c1 minus c2 will be c. So therefore I will be x plus cot x minus 1 by 3 cot cube x. Just put the values of I1 and I2 and simplify. That's all. Now let us see the 10th question. So it is given that integrate 1 plus tan x by x plus log of secant x dx. So now we can see that if I differentiate x plus log of secant x, so if I differentiate that, what we will get, x's differentiation is 1, and log of secant x, the differentiation will be first log's differentiation, it will be 1 by secant x into differentiation of secant x, that is secant x into tan x. Now secant x tan x will be cancelled out, so it will be 1 plus tan x, which is the numerator. So therefore 1 plus tan x dx is dz. Now it is very easy. So in this kind of integration, what is important? The important is which function you are taking as a substitution. once you can find out which the proper substitution, it will be very easy. So therefore it will be this is dz, so this one become dz by z, dz by z. Now it is log of mod z. Now you replace the value of z by whatever you have assumed, that is x plus log of secant x equals to z. Just replace the value of z. So log of mod x plus log of secant x plus c. So what is important for this kind of sum? That is the proper substitution, to understand what is the proper substitution. Okay, so let us see the question number 11. Question number 11 is 1 plus sine 2x divided by x plus sine square x. So you just you have to know that sine square's integration is sine 2x. Okay, so since sine square x is you just memorize this kind of formulas. This is a very simple formulas. Sine square x differentiation is 2 sine x, then sine x integration differentiation is cos x, 2 sine x cos x. So therefore it will become sine 2x. So as much as you remember this kind of formulas, so it will be helpful for you also. So therefore x plus sine square x, if you see this, you can automatically find out that the differentiation of the denominator is the numerator. So from now on you can also memorize this thing. Sine square x differentiation is sine 2x. Also cos square x differentiation will be minus sine 2x, because cos square x will be 2 cos x and into cos x differentiation is minus sine x, so minus sine 2x. So if there is a cos square x, then there should be a minus sine 2x. So memorize this kind of tricks. So therefore x plus sine square x t, so therefore it will be 1 plus sine 2x into dx will be dt. So ultimately it will become dt by t. Now the process is simple. It will be log mod t, then replace t, done. Now let us see the next question. The next question is 2x square minus 1 by x into x square plus log x. Simply you can see that x square minus log x is there, and there is a x also in the denominator, so that means you have to take this one as the substitution, x square minus log x. Since there is a 1 by x, so log x should be there for the proper substitution. So now if we differentiate this whole thing, what we are getting? We are getting 2x, x square's differentiation is 2x, minus log x differentiation is 1 by x. So therefore now again if we do the LCM here, so it will be 2x square minus 1 by x. So 2x square minus 1 by x. So this will become dz. Now the process is simple after that. So 2x square minus 1 by dx, 1 by x, 2x square minus 1 by x into dx will become dz. This thing will become dz, and this thing will be 1 by z. Hence it will be log mod z plus c. Now you replace the value of z, so it will be log of mod x square minus log x plus c. Now let us see the 13th question, that is integration of e to the power 2x plus 1 by e to the power of 2x minus 1 dx. So this integration is a little bit tricky, but not that much difficult. Just see, if I divide e to the power x in both numerator and denominator, then it will be like this. E to the power x, if I divide e to the power x, so e to the power 2x by e to the power x is e to the power x plus, this will be e to the power minus x, because 1 by e to the power x. Same thing denominator, in the denominator e to the power x minus e to the power minus x dx. Now if I consider these thing as z, so if I differentiate, it will be e to the power x, e to the power x as differentiation is e to the power x, minus e to the power minus x differentiation is e to the power minus x into minus 1, because a minus is there. So therefore minus plus e to the power minus x into dx. So therefore this into dx will become dz. So therefore it will be dz by z. So dz by z, simply log mod z, log of e to the power x minus e to the power minus x plus. Now I think you can understand the main funda of this question, that is what should be the proper substitution. And in the beginning of this video, as I told that I will solve 20 questions, so there are 7 more to go. So I must tell you that pause the videos, and for each and every questions when I solve, you pause the video and solve it first, then you match your answer with me. So let's see the 14th question. The 14th question is secant square root x by root x dx. Now pause the video and solve it, then match the answer. So if you have solved this, let's see what is the answer. The answer is, let root x equals to z. I will consider root x as z. We know the differentiation of root x is 1 by 2 root x dx. So this will be dz. That means we need to adjust this 2 because there is no 2 here. So that means we need to multiply 2, divide 2. So this will be secant square root x by 2 root x into dx. So this will be 2 into secant square z dz. Now we know that secant square z integration is tan z. So now this will be 2 tan root x plus c. Now let us see the 15th question, that is x plus 1 into e to the power x by cot square x e to the power x dx. So pause the video again. Pause the video, solve this question, then you will match your answer. So let's see the answer. This is x plus 1 e to the power x. Now if you take x e to the power x as z, so differentiate this. So it will be first the differentiation of the first function, leave the second, then differentiation of the second function, leave the first. That is a UV formula. If I do this way, this will be x e to the power x plus e to the power x dx equals to dz. Or we can take e to the power x common, so we are getting the numerator x plus 1 e to the power x dx equals to dz. So it will be dz by cot square z. Dz by cot square z. Now cot square z is basically tan square z. Now to differentiate this tan square z, it's you have to find out in terms of secant square. So it will be secant square z minus 1 dz. So it will be tan z minus z plus c. Now you replace the z, tan of x e to the power x minus x e to the power x plus c. Now let us solve the 16th question. So I have to do this way. So it is given that integration of root tan x by sine square x dx. We need to integrate it. Now pause the video and solve it. I think you have paused the video and solved it. Now let me show the solution. It is I is equals to root tan x into, now this sine square x is in the denominator, so let me bring that sine square x in the numerator. It will be cosecant square x dx. So again we can take that tan x in the denominator, so it will be root cot x in the denominator, so it will be cosecant square x by root cot x dx. So this is the trick here. Now if we consider cot x as z, so obviously cosecant square x I will get. So now let me consider this cot x as z, so it will be minus cosecant square x dx, which is equals to dz. Now we have to adjust the negative sign, so minus into minus cosecant square x dx. Now this will become dz. So minus is outside, root cot x will become root z. I told that all the time we can consider, if there is a root, we can consider z also. Cot x we can consider z also, because in my previous sums I used to take z square because of this root. To avoid this root I used to take z square. So here I am taking only z. So this will this doesn't matter. So that is why I took z here. So therefore dz by root z. Now this will be z to the power minus half dz. Now z to the power minus half, integration of z to the power minus half is minus, so outside, so z to the power minus half plus 1 by minus half plus 1. Now if we calculate minus half plus 1 will become half. So there will be half in the denominator also. This half will come as a 2 in the numerator. So minus 2 and z to the power half will become root z plus c. Now this root z, as z is equals to cot x, so it will be minus 2 root cot x plus c. Now 17th question. The question is integration of sine to the power 7x plus 7x dx. Now here I want to say something. Sine to the power, you have to check there what is the power. The power is even or odd. If it is even, you can do directly without taking substitution. I have solved this kind of sum taking even power in my previous video. I will give the link in the description box, so you just go and check there. I have solved, I think, sine to the power 4x. If there is even power, then the process is different, and if there is odd power, then the process is different. So if there is an odd power, you have to do using substitution. Now solve this. Pause the video and solve it. So I hope you have solved, you have tried to solve. Let's see what is the solution. So here what we have to do, we need to write in this way: sine to the power 6x into sine x dx. Now I will write sine to the power 6x as sine square x whole cube. Now that sine square x will be written as 1 minus cos square x. So it will be 1 minus cos square x whole cube sine x dx. Now it is very easy. Now you can understand what you have to do. You have to consider cos x as z. So it will be minus sine x dx will be dz. So now before doing that, I have simplified this whole cube. So it will be 1 minus 3 cos square x plus 3 cos to the power 4x minus cos to the power 6x into sine x dx. Now we will consider cos x as z, which is, from there we can write minus sine x dx will be dz. So therefore minus we need to adjust here. So minus we need to multiply. So minus sine x dx. Now minus sine x dx will become dz, and all the cos x will become z. So it will be z square here, z to the power 4 minus z to the power 6. Now simply integrate them. Z integration is, one integration is z. This one will be z cube by 3, z 5 by 5, z to the power 7 by 7. Hence, we can write z as cos x. So therefore, cos x minus 3 cancelled out, cos cube x plus 3 by 5, cos to the power 5x minus 1 by 7, cos to the power 7x plus c. Now let us see the 18th question. Log of tan x by 2 by sin x dx. Try this sum. This sum is very interesting sum. Pause the video, solve it. Now let's see what is the solution of this question. I hope all of you have solved. Let's see. So here log of tan x by 2 by sin x. I must tell you, if there is a log, you have to take log as a substitution. So take log tan x by 2. So if I take log tan x by 2 as z, now if I differentiate, first of all log's differentiation is 1 by, so 1 by tan x by 2 into tan x differentiation is secant square x by 2. Now x by 2's differentiation is 1 by 2. So ultimately it is coming 1 by 2 secant square x by 2 by tan x by 2. Now here I bring that secant square x by 2 from numerator to denominator. So it will become tan x by 2 cos square x by 2. Now we know that tan x by 2 means sine by cos. So there is a cos in the denominator, so cos cancelled out. So one cos will be cancelled out. So therefore it will be 1 by 2 sin x by 2 cos x by 2, which is sin x. So therefore dx by sin x equals to dz. Dx by sin x will be dz. So this will be dz and this will be entirely this thing as z. So ultimately it is coming I equals to z integration of z dz. Now we know what is the integration of that, z square by 2 plus c, and replace the value of z. The value of z was log of tan x by 2. So it will be log of tan x by 2 whole square by 2 plus c. Cube root of x plus 1, we need to integrate this function. Now again pause the video, try to solve this question. So what is the condition? Can you solve this question? Now this question is a little bit tricky, but trick is the beauty of mathematics. So let's see what is the beauty of this question. Now here it is given that we can write this thing is given, so we can write a root over of x plus 1 as x plus 1 whole to the power 1 by 2 and cube root of x plus 1 as x plus 1 whole to the power 1 by 3. Now let us consider x plus 1 as z to the power 6. Definitely if I differentiate this side, it will be dx and this side will be 6z to the power 5 dz. So therefore we can write 6z to the power 5 dz as dx is that one. Then x plus 1 is considered as z to the power 6. So we can write z to the power 6 whole to the power 1 by 2 plus z to the power 6 whole to the power 1 by 3. So therefore we can write this 6 outside and it will be z to the power 5 by, now if I evaluate it will be z cube, and if we evaluate this it will be z square. Now what we can do, we can take common z square. So if we take common z square, so it will be z plus 1 in the denominator. Now z square z to the power 5 can be cancelled out. So it will be 6z cube by z plus 1. Now in the denominator it is z plus 1. So in the numerator we can write z plus z cube plus 1 minus 1. Because we know there is a formula of z cube plus 1, and in the formula of z cube plus 1 there is z plus 1 as a factor. So let me distribute this thing. So z cube plus 1 by z plus 1, 6 into 6 is there. Now this 6 will be distributed here also, so minus 6, this will be simply dz by z plus 1. Now z cube plus 1, the formula is z plus 1 into z square minus z plus 1. Now z plus 1 can be cancelled out, so it will become 6z square minus z plus 1 dz. So this is the story of this side. Now what is the story of that? The story is very simple. 6 into, now integration of that is log of z plus 1, mod z plus 1. So we can write 6 log of mod z plus 1. Now here we need to integrate this side. So if we integrate, it will be z cube by 3, then z square by 2, then z. So ultimately it is coming 6 into z cube by 3 minus z square by 2 plus z. Minus, now this log will go in the power. So it will be log of z plus 1 whole to the power 6. Now you are thinking, where is the mod? Why I have given the mod? Because inside log there cannot be negative. That is why in the formula mod is there. Now if you do whole to the power 6, it will be always positive. So you can keep mod, don't keep mod, doesn't matter. So therefore I am not keeping the mod here. So therefore this will be like this. Now let me just multiply 6 with all these terms. It will be 2z cube minus 3z square. Now plus 6z minus log of this. Now replacing the value of z. So what is the value of z? Let me see. The value of z is x plus 1 whole to the power 1 by 6, or 6th root of x plus 1. Okay, so let's see what is the value here. So z plus 1 whole to the power 1 by 6, okay, or the sixth root of x plus 1. Now there is a whole cube, so it will be only root of x plus 1. Now there is x plus 1 whole to the power 1 by 6, so 2 by 6 will become 1 by 3 in the power, so it will be cube root of x plus 1. And z is sixth root of x plus 1, so this one is the value. Now here the value of z is sixth root of x plus 1 plus 1 outside of this root whole to the power 6 plus c. Now I hope you can understand the beauty of this sum. Now let's see what beauty is waiting next. The next and final sum for today's video, that is integration of dx by x square into root over of x square plus 1. So again pause the video and try this sum. Let's see what kind of trick we can use. Now I think you have paused the video and solved the sum. Now let's check the answer. So here we need to modify the integration. So here we have to do dx by x square. I am taking common x square inside this root. So it will be x square. If I take common, so it will be 1 plus 1 by x square. Since there is no x square, so it will become 1 by x square. So therefore we can write dx by x cube into root over of 1 plus 1 by x square. Now if I differentiate 1 by x square, the power will decrease, so it will be 1 by x cube. It will come 1 by x cube. So instead of taking 1 by x square, I will take 1 plus 1 by x square as z. So this will be 1 plus x to the power minus 2 equals to z. Now if we differentiate, it will be minus 2x to the power minus 3. See, the power decreased and it will become minus 2 by x cube dx equals to dz. Now we need to adjust this 2 here. Now to adjust 2 here, 2 and minus a negative sign, so we need to divide minus 1 by 2 and we need to multiply minus 2. Now minus 2 by x cube dx will be dz, and this is root z, so dz by root z. Again this root z will go there, so now you can integrate dz by root z. Just now a few questions back I solved this kind of integration, dz by root z. So it is basically z to the power minus half. Now integration z to the power minus half plus 1 by minus half plus 1, so it will be z to the power half by half. Now this half is in the denominator and this half is in the numerator, so this half and that half cancelled out, so ultimately half will not be there, so only minus root z. Now the value of z is 1 plus 1 by x square as we have considered, so this will be root over of 1 plus 1 by x square plus c. Now you can do this step, it's up to you. You can keep the answer in this way also, then also it is correct. Now that's all for today, and I hope you can understand the integration by substitution and solve more and more questions to become a champion of integration. Thank you.